So what is a matrix? So matrix is nothing but a representation of 2D 2D coordinate in a numerical form. Okay, so what it is like here, if you see as a definition, so this is like defined as an m cross n two-dimensional array of real numbers where m is the number of rows and n is the number of columns. All right, so intuitively you can understand it as, yeah, so you can understand it as like you have uh, like this uh, this x coordinate, let's say you have this y coordinate. All right, you if you have a number here, so you have two numbers to represent two. Actually, if this is like here 2 comma 3, just intuition I'm giving you, it means if you want to represent this point, you have to say, okay, 2 units you have to go in the x direction and 3 units you have to go in the y direction. The similar thing in matrices. What happens, uh, you have a structure like this. All right, and this actually represent your rows, right? This is your row and this will be your column C. So you have multiple elements here in this, and if you have element here in here, you represent it as R comma C, or you can say M comma N. All right, this is N. So what M is, it represents in which row it is present, that element, and N represent in which column it is present. Okay, so matrix is referenced by two element subscript. If you remember in vectors in last class which we were talking about, in that we had x1. All right, x1, this was the subscript, and I told you it means like in a x vector, this is the first element. If you have here if you write x5, then it means in x vector the fifth element. All right, here that comes down. Now you have two subscript, two element subscript, because this is two-dimensional representation. Okay, so here we will have two element subscript. If you say here in example, if you say a24, okay, what a24 means is like it correspond to an element in second row, fourth column. Okay, you cannot just say okay, a2 was earlier the second element, now a24 means the element that is present in the second row and the fourth column. So here a24 is this one. If you let's say if you have a 3 1 third, you might have like this, and dot dot dot, you might have like 1,000 rows, 1,000 columns. So if you want to represent or extract any element, then you have to tell, okay, I want to extract the fourth row, fifth column element. So like that you denote, and you denote it as the two element subscript. Okay, that is pretty general thing that is like you have to follow whenever you are writing. That's a good practice to follow. You cannot just write okay a12 I want to do. You have to write it as subscript a1. All right, so next is matrix arithmetic. In matrix arithmetic, what you have to do when you are doing the addition, then both the matrices should must have the same size. So what same size here means, it should have same size. It means like if a matrix is, if I write a 2 cross 2, it means a matrix A has two rows and two columns. Right, you cannot add it with a 3 cross 3. Okay, if you have three rows and three columns, you cannot add. What you can add is like a2 cross 2. If you want to add it with some other matrix, it should have the same size, and that is the subscript which I'm talking about here, 2 cross 2. So if you, this is another thing which you should know. If I write a22, that is different from a2 cross 2. Okay, a22 means this is an element where this a22 will represent like an element which is present in the second row and the second column. All right, but a2 cross 2 means it has two rows and 2 columns. And yeah, the where were we? We were talking about addition of 2 matrices. So here, if you want to add 2 matrices, then you should have this same size. That is 2 cross 2. If you are adding with, you have to get the 2 cross 2 matrix. If it is 3 cross 3, then you can add with this matrix, that is B 3 cross 3, like this. All right. So if I want to give you an example, so here I'll give, let's say I have taken 1, 2, 5, 6. All right. This is A 2 cross 2. And if I keep B 2 cross 2, that we have established that it cannot be other than 2 cross 2, right? So it should be 6, 8, let's say 3, 4. Okay. So how addition will happen? The corresponding element, this is like 1. If you add now A plus B, if you write, so it will be 1 plus, this is 6, right? This will be 1 plus 6. Corresponding element that will be added, 2 plus 8, 5 plus 3, and 6 plus 4. And resultant will be 7, 10, 8, 10. Right? Like this we add. So this is like pretty general. Element wise addition will happen. Okay. Similarly, if the next topic is like a scalar multiplication of a matrix, so in that, if you are adding, again the same example, this example I'll take. If you want to add multiply by 2, let's say, to whole matrix A 2 cross 2 matrix, so to each and every element, that scalar value that will be added, sorry, multiplied. So what it will be, 2 multiplied by 1. Okay. 2 multiplied by 2, 2 multiplied by 5, and 2 multiplied by 6. Okay. So the resultant will be here. The resultant will be 2, 4, 10, and 12, right? So it's very simple. Just I wanted to give you an example. So one thing which you should remember, that whenever you are doing the addition, the element wise sum will happen. The corresponding element like A11 will be added to B11, A12 will be added to B12, and similar to that. This pattern will be followed to the whole matrix. Okay. And if you the next part was when we are multiplying scalar to a matrix, then that scalar value that will be multiplied to each and every element of the another matrix. Okay. The next is matrix multiplication. Okay, so in matrix multiplication, one thing, how it happens, right? How it happens. So here it does not have to be similar size, but you have one constraint here. Two matrix A and B, if you are multiplying, one thing you have to see, the first matrix column and the second matrix row, this should be same. No matter what number you have, this can be 1,000, and this can be, let's say 2. Any number it can be, but the C and R, it cannot be different. So it should be 1,000 multiplied by 1,000 into 4. That's like 1,000 rows you have, 4 columns, and it should be, or it must be, I must say, like 4 into 2. These two values should be same. Okay. So this is like the rule which you have to follow. Otherwise, your multiplication will not happen, right? So this row here, the similar thing it is written. This row, and here this column, and here this row, these two should be same. Now what will be the resultant, right? So in these cases, if you this is like pretty straightforward. If you have 2 cross 2 here, if it is like 2 cross 2, it is also 2 cross 2 in this case. The resultant will be what? 2 cross 2. All right. This here we saw this was 2 cross 2. In this case also, if you are multiplying by scalar, it doesn't matter. Each element will be multiplied and the resultant will be the same. But here, when you are doing matrix multiplication, so the resultant, what will be the shape of this resultant. I mean, what will the size, right? Which we are talking. So here, what it happens, this number, just have to omit this number, and the resultant will be 1000 cross. This will be the resultant matrix shape. Okay. So yeah. So how the matrix multiplication happens? This I am showing in this example. So before that, I'll talk about two properties. That is like multiplication. Matrix multiplication is associative. It's like if you are doing this A dot B. Let me just check one chat I'm getting. Okay. So okay, I'll explain multiplication. Don't worry. I'll explain multiplication here next in example I'll take, and then it will be more clear. Don't worry. So what is happening here, the next is like matrix multiplication, that is associative. If you are multiplying this, if you are multiplying a, first you are doing this operation, right? And then this is the first operation, and then you are multiplying with a, and then it's the second operation. So this will be equal to if you multiply these two first, and then with the resultant you are multiplying with c. So this will give you the similar result. Okay, but the change will be matrix multiplication is not commutative. A dot b will not be equal to b dot a. This we will see in example. So so I got one request, like I should explain the matrix multiplication again, so I will explain that. So here what happens, one the rule which you should keep that in mind, that whenever you are multiplying two matrix, then what you should keep in mind is a matrix. Let's say I keep as 1000 rows it has, and columns it has, let's say 5 columns, and I want to multiply with this, which I'll write as dot, which it is written here, right? So dot here. Here one rule you have to apply is this: it should be 5 cross any number you can put. I can put it as let's say 22, any number I have chosen. So this number 5, this 5, it should be same. This a, this is what, if you say for in a matrix it has 1000 rows and 5 column, in b matrix you have 5 row and 22 columns, right? So this, the first matrix, this column, and the second matrix row, that should be same. All right, that should be same. This should be same. That is, if you that is not same, then matrix multiplication will not happen. Okay, and when you are multiplying it, now it is same here, it is 5 5. It, if it would be like 4, then like matrix multiplication will not happen. So what we will do, what we are doing after the class, we will share the Jupyter notebook where we have implemented all of these things in Jupyter notebook, and you will see that when you change these numbers, then you will see error. Okay, matrix operand will not happen, kind of error you will get there. So now what will happen when you are multiplying, there will be some resultant, right? There will be some resultant that I am representing it as c. So the c, what is the shape of that c? I am multiplying by a matrix where it is like it has 1000 rows 5 columns, with another matrix that has 5 rows and 22 columns. So what, how many rows and columns this c will have? So what will happen, just thumb rule, what you have to follow is 5 5, that is common, just remove that. The resultant will be 1000 into 20. Right, this will be the resultant. Okay, so now like how matrix multiplication happens. So we saw in addition what we were doing, we were just adding element wise. So how in matrix like what happens, like matrix multiplication if we are doing, so how it will happen. So here in this case, let I have taken a, that is 2 cross 2. All right, and here the next thing is b, that is also 2 cross 2. It is not necessary that it both should be equal. It would be like if it is 2 cross 3, that will also work as long as this value and this value is same. It doesn't matter what you have here. All right, so Now, how matrix multiplication happens, just I'll give you a quick recap about it. So here, if I am doing A dot B, right? If I am doing A dot B, so in this case, this first element, this element, how it came. So what you do, you multiply first with this, all right, with this. You multiply this row with the first column. So how it came? 3 multiplied by 1. Okay. So this 5 came 3 multiplied by 1 plus 2 multiplied by 1. And that is how this 5 came here. Now again, how this 2 came? So this same 3, 2 will be multiplied with the second. All right. So this is like the first element. This we got. Now second element I'm talking about. So 3 multiplied by 0 plus 2 multiplied by 1. So 3 multiplied by this is 0. 2, it comes here as 2. 1, how it will come? If then again this next row that will come from this row 0 1, so it will come as 0 multiplied by 1, because the corresponding 0 will be multiplied by this one, and this one will be multiplied by this one. So plus 1 cross 1. All right, and this will come out as, because this is 0, so it will come out as 1. And similarly, you can see 0 1 multiplied by 0, this will multiply with this, right? 0 corresponding to 0, that is 0, and 1 multiplied by 1, that will come as 1. Okay, so that this will be the resultant matrix. And if you think about what will be the resultant here, so it should be, if you this is row here, this column and this row, these two are same, you have to remove this. The resultant here in this case is 2 cross 2 only, right? Now if you do B dot A, just I want to show you like how this multiplication is not commutative. So if I'm doing A dot B, so A dot it means keeping A as your first matrix, that this is your first matrix. Now if instead of keeping A as your first matrix, if I am keeping B as my first matrix, then if you do this by yourself, then you can see this will be the matrix which you will get, and that is not equal. Right? So that is the thing. Matrix multiplication is not commutative. It's not like 4 into 5 is equal to 5 into 4, right? But in matrix, this is not happening. This like it will be different. The matrix A dot P, it will not be equal to P dot A. Okay. Yeah. So a matrix transpose I was talking about earlier. So here in this case, like if B is equal to A transpose. So if what this Ji, what this Ji represent? Here is Ji represent like the element present at in A. Let's say if I'm talking about A, which is let's say 2 cross 3 matrix. All right, 2 cross 3 matrix. And how I will write, just some random numbers I'm taking here. Let's say 1, 2, 3, 4, 5, 6. These are random numbers, just I'm taking the sequence manner, it doesn't matter. Just I want to show it has 2 rows, right? These 2 are rows and these 3 are 3 columns, right? Now, if I want to, if I'm writing Ji, it might be any number. Ji might be, if I, instead of J, I am talking about, let's say I take 2, 3. Or to make it different from 2 cross 3, I'll take 1, 2. This is, let's say, J and this is I. So what this means, A, 1, 2, this is what value? If you think about it, the first row and 2 columns, so this is the value. This 2 here is A, 1, 2. Now if you transpose it, if 2 cross 3 matrix, if you transpose it, how you represent it? It's like you write it as a superscript. On the top you write as T. So A 2 cross 3, if you transpose it, then what it will be? It will give you a resultant that is B, let's say, and it will become 3 cross 2. Okay, it will become 3 cross 2. It means now each element, this 1, 2, this element 1 2 here, it will now convert it to this 2 will now it will go to the 2 1. All right, it will go to the 2 1. So how it will happen? Just B matrix, that will be 3 to 2, right? Now it has how many rows? It has 3 rows, 2 columns. So it will be something like this, right? So what happened? Now you see in this case A12 in A matrix, A12 was 2. But now if you see 2 has come to A21, right? The second row, first one. All right. So it has been now interchanged. So that is the concept here. This is very simple. So if you think about it, just this element here, ij, if you had this a here, ij, it will be basically interchanged. But what happened when you have, let's say, one another example that what I want to see, I want to give you another example where let's say it's a 3 cross 3 matrix. Okay, so 3 cross 3, I'll just take 4 3 1 3 5 7 9 11 13 and then 15 and then 17. Okay, so if a is this matrix, and if you are transposing it, so it is basically 3 cross 3, so transpose will also be 3 cross 3, but you will have the number interchanged. But in this case, this in middle value, this will be the same, right? This will be the same, like 1 9 17. Just to make more clear, I'll just remove the. All right, so if I am doing this A transpose, then what will be the A transpose value? This 1 9 and 17, this will not change, this is not going anywhere. This 3 and 7, that will be interchanged here. This 3 will come here, 7 will go there. This 5 and 13, these two will be interchanged, because if you think about it, this is 3 comma 1 and this is 1 comma 3, right? These two places will be interchanged because this will come here 5, because we are transposing it, it will come here 13, and then 11 15, this will be interchanged. In between these values will be same. Okay, we have this transposition rule. If you are doing A multiplied by B, and then this is your first step, and then the resultant you got as C, and you transpose it, that will be actually equal to first you transpose B, and then you transpose A, and then you multiply it. So what it means actually, this first you multiply A and B, then you are transposing, or you first transpose A B, and then you transpose A, and then you multiply, then also result will be the same. All right. Okay. So now the next thing is determinant of a matrix. How we calculate the determinant. So straight away I'll go to the formula of it, like how the process, like how you determine the determinant of a matrix. So here, how we do, let's say I'll take this example matrix. This is 3 cross 3 matrix, and in this you have these elements 3 0 2 2 0 minus 2 0 1 1. Okay, these are rows. You have three rows and 3 columns. That is clear now. So if you have to calculate the uh, if you have to calculate the determinant of a matrix, then what you do, you have to check first, like this. You what you do, you first this element, right? This whole row, this column, and this first light, like this, like, just to give you this example. Okay. Yeah, this line and this line, you freeze it. Okay, and the number you have here, 0, -2, 1, 1. If I am, then what I'll do, I'll multiply it by 0 into 1 minus, okay, this minus will come here, 0 into 1, and then I'll minus -2 into 1, and I'll multiply it by value 3. Okay, so why this two lines have come here? So why I've done this, like for 3, for this 3, I am calculating the first value. So that's why for this 3, the two lines will go, right? These two lines, you just draw it, and these two will be freezing, it will be frozen, and the rest, for the rest matrix, you have to do this operation. You have to calculate the rest determinant. So for that, you have to freeze these two lines, and then the rest, you have to multiply it like this. For the middle one, if you talk about this middle one, so here again, from this 0, you will have these two lines that will intersect this 0. If you go by row wise, and if you go by this column wise, all right, this is row wise, this is column wise. If you just draw a line in the rest element, you do the same thing, 2 into 1, this is this element multiplied with this element, and then negative of -2 into 0. And then here, if you see the first element, I was multiplying this whole value with 3. Here I will do this with 0 minus this. This minus I have to keep. So what happens? First element will be positive. This will be positive. Then you have to put the negative, and then again you have to put the positive here. Okay, so this value, then again the third element, this 2 here, in that again two lines are going through this is row wise, one line is going, and then column wise, whatever is left, you have to do that 2 into 1 here, minus 0 into 2, 0 into 0. Okay, and if you then again you multiply this whole value with this 2. All right, you do, then you do the whole, you do the sum, 0 into 1, that will be 0, minus 2 into 1, that will be -2, and here we have -2, so that comes out to be 2, right? Minus minus plus, and 3 into 3 multiplied 2, it will come here. This whole value will go to 0 because we are multiplying it with 0. Next is 2 into 1, this is also 0. All right, so it will come as 2 into 2, so the determinant is 10. This is how you calculate it. It's very like intuitive when you are, let's say, doing 3 cross 3. So first element you have to freeze, you have to draw, think of it as a two lines you have to draw, that will pass through that element, and then the rest element you have to do this multiplication, and the element where you pass the two lines, that you have to multiply it with, and then first will be this, first will be positive, then this will be the negative, and this will be the positive. This is the basically step of it. This is how you calculate the determinant. Next thing is the inverse of a matrix. So the inverse of a matrix, how you calculate it? You do for calculating the inverse, it is like adjoint of A, and then you like divide it with determinant of A. Determinant, we basically I told you like how to calculate it. All right. So now next part will be adjoint. I'll explain it. So they see like why, where this inverse of a matrix will be used. Okay, so where this inverse of a matrix will be used here, if you think about it, inverse, if you remember, when you have, let's say, two matrix like this, and here you have 2x1, x2, and you are solving some equation, linear equation, if you think about it, and you have this c1, c2. So if you want to get the value of x1, x2, what you do, you just take it as a inverse, right? You take it as this A matrix, it will be this inverse like this, then you will get the value of x1 and x2. So in linear transformation and like in linear regression, this inverse thing is used. Okay, and the next thing is like inverse is only defined for non-singular. Non-singular, what it means? Non-singular is like determinant should not be 0, because you can see if determinant will be 0, then like it cannot be 0, right? Then the whole value will be undefined. So you cannot divide by 0. Okay, and then it should be square matrix. Square matrix, it should be, it means like it should be 2 cross 2 cross 2 or 3 cross 3. The number of rows should be equal to number of columns. Okay, so how we calculate it? It's pretty much similar with how we were calculating determinant. So here in that case, what was happening in determinant, we were just talking about this one row, right? This 3, 0, and 2. Only for this, what we did, we froze this line, these two lines we draw and then calculated this value, and then again draw these two lines and then calculated this next value, this one. So like that, now what you have to do, you have to do with each and every element, and whatever value you are getting, that will come down here. So if you see, for first one, the similar thing it is happening. For 3, it has written 0 multiplied by 1. So it is 0 multiplied by 1. And then minus of minus 2 into 1. That is similar thing it is happening. Similar, if you see the next one, 2 into 1 to minus 2 into 0. So this similar thing. So these only these three terms we calculated for determinant. For calculating the adjoint first, you have to do for each and every element. And the resultant, that will be the matrix of minors that we say. All right. So this will be the resultant matrix which you will get. Okay. After doing the similar this process for each and every element. Okay. Then step 2 will be this positive, negative. This sequence you have to multiply it with. Right. So here, if you see in determinant, I was talking about first you have to put the positive and then negative and then positive. The similar sequence, it will be repeated over a whole matrix, that will be positive, then negative, negative, and this similar alternate sign will be applied, and then this will result to you the matrix of cofactors. Okay, this is the step 2. So step 2 was what? Step 1, you have this matrix of minors, which you calculated freezing all, taking all elements and freezing the drawing one line over in row wise and column wise. You will get this matrix of minors, and then you multiply it with signs. You get this number. Then you transpose it. This is like here in this case, you transpose this matrix of cofactors, and then the last, you have this transposed value. In the end, what you do, you divide it with your determinant. So you can see here, I wrote here educate of a, determinant of a, to this value what we got after the transpose. After that step 3, what matrix we are getting, that is basically educate, and when we divide it by determinant, then it gives us the inverse. All right. This is the step of calculating inverse of a matrix. It is used when I was already talking about linear regression. When you want to solve multiple equations, then this matrix multiplication happens. You have to calculate the inverse of it. But the thing is, like, you cannot have the determinant of a matrix 0 in this case.